Hi everyone, this video is part 2 of data preprocessing. So let's see the agenda of today's lecture. First, let's talk about what is data encoding. Data encoding is a data preprocessing technique that transforms categorical variables into numerical variables, which can be used as input in machine learning algorithms. The purpose of this technique is to make the data compatible with machine learning algorithms that generally operate on numerical data. There are different techniques for data encoding, including the following: label encoding and one-hot encoding. So let's talk about label encoding. Label encoding is a data preprocessing method that involves assigning a unique numerical label to each category within a categorical variable. This technique is particularly beneficial for ordinal variables where the order of categories holds significance. In R, the factor function or the label package can be utilized to execute this technique. So, when to use label encoding? Label encoding is appropriate for ordinal variables where the order is important. For example, if you have a categorical variable with values such as small, medium, and big, you could encode them as 1, 2, and 3, such that the big can represent 3, and small can represent 1, and medium can represent 2. Now let's move to R Studio to see how we can do label encoding in R. Well, first of all, I will read the CSV file. I will say HR data, and I will use the function of read.csv. And today I'm going to use a different data set with the name of hdata.csv. Now let's use the head function to see the columns and rows of this data set. You can see that inside this dataset, you have different columns such as certification level, last evaluation, and so on. Now, there are two categorical columns. One is department, and the next one is salary. So you can do label encoding on the salary column because this contains an order of the salary values. Let's say unique, and I pass the HR data and I say take the salary column. All right. Now you can see that there are three categories: low, medium, and high in the salary column. I'm going to label encode low as 1, medium as 2, and high as 3. Now let me prove by using the aggregate function that why this column contains the ordinal values, or why is it important to do label encoding on this categorical feature. So first I will say mean cell, and inside the mean cell function I use the aggregate function, and I say that take the HR dataset, all right, and take all the rows, and here I will use the combine function, and I say that take the column of satisfaction level and take the column of last evaluation, and I say take the variable of number of projects, and I say take the average monthly hours, and here I say that give me the mean value of salary according to these columns and group it by equals to list, and I say take the HR dataset and the column of salary. And in the last, I use the fun function, fun equals to, and it should be mean. And here I say print mean cell. Now you can see that these are the unique values inside the salary column, which is high, low, and medium. And you can see that the certification level and the last evaluation and the number of projects, and based on all of these columns, the salary depends. And now I hope that you understand that why we are going to use label encoding on this categorical column. So in order to do label encoding, I will first create the labels. I will say salary labels, and inside this, I use the combine function and I say that give low the label of 1 and medium the label of 2 and high the label of 3 because it has a higher importance. All right. And here I say HR data, and I create a new column of salary label. And inside this column, I say take the salary labels and apply it on the HR dataset variable or feature of salary. But before moving forward, I say take the HR dataset and I use the subset function, and I say take the HR data and select equals to minus salary. Because you know that now I have a new column of salary label that have the label encoding on salary. So I'm going to drop the original salary column. And here I just say head and HR data. Let's run it. As you can see that the very first value was low, which is encoded to 1. And then we have 2 medium that are encoded to 2. As you can see, the very first one is 1, the next 2 are 2, and the last 3 are 1 because they were having the value of low salary. Now let's move back to slides. Next, we have the technique of one-hot encoding. One-hot encoding is a data preprocessing technique that generates a binary variable for every category within a categorical variable, where each binary variable denotes the presence or absence of a particular category. If the value is 0, then it denotes that there is the absence of this value. However, if it's 1, then it denotes the presence. In R, this technique can be executed using the model.matrix function or the dummy voice function available within the caret package. So when to use one-hot encoding? One-hot encoding is appropriate for nominal variables where the order of the categories does not matter. For example, if you have a categorical variable with values red, green, and blue, you could encode them as binary variables, indicating whether each color is present in the data. Now let's move to RStudio to do one-hot encoding. Now, first of all, I will use the same thing, indicating whether each color is present this time in the data. I'm going to apply one-hot encoding on the column of department. So first I will say unique, and I will say take the HR dataset and the column of department. And you can see that you have these departments, which does not have an order. I will say mean department, and I use the same HR data function and the same columns. And here I say that list it by department, and the function should be mean and display the mean department here. All right. Now you can see satisfaction level, last evaluation, and these column values, the mean average values according to the group of department. Now these department values are not ordinal, so let's apply one-hot encoding. Now, at first I say that encoded variables, and inside this column I use the model.matrix function, and I say that apply the one hot encoding on the department variable or column -1 so that it removes the original or the very first encoded variable. And here I say data equals to HR data. All right. And here I will just say head and I say encoded variables. Now you can see that your department of accounting, department HR, IT, all have been encoded into binary values. Now you can observe one thing here that all of these columns are having the value of 0, but department have the value of 1 in the first row. It means that the department is not accounting, it's not HR, it's not IT, but it's the department of sales. As you can see above here as well, that for the very first 6 rows, the department is sales. And that is why the value is 1 that indicates the presence of sales department. Now, what I will do here is that I will say HR data, and I use the cbind function, and I pass the HR data first, and then I say that attach or bind the encoded variables with this data frame. And here let's just say head HR data. Perfect. So you can see all of the columns here, and you can see that the department column is now one hot encoded, and these are the encoded variables. And hence now it's better to remove or drop the original department column, which I will do by saying say HR data, and I use the subset function, and I pass the HR data, and I say select equals to minus department, and here I will say call names HR data. Now you can see that these are your column names. Now let's move back to slides. So this is the end of today's lecture. You have learned today how to do one hot encoding and label encoding as well. So I have got some homework for you. Apply the 2 encoding techniques that we have studied today. Now here is the link of the dataset and you can practice on it. Now good luck. See you next time.